Docker Swarm Management. In this section, we'll learn how to manage a Docker swarm. We'll start by learning how to create a new swarm and how to add nodes to it. We'll then learn how to manage node availability. Next, we'll learn how to remove a node from the swarm. Finally, we'll learn how to back up and recover a swarm. Initializing a swarm. In this video, we'll create our own Docker swarm. We'll start by learning what Docker swarm is and why you would choose it for your Docker cluster. We'll learn what steps are needed to prepare your servers to be swarm nodes. And finally, we'll create our own swarm. Docker Swarm is Docker's native tool to manage containers running on a cluster of servers. Swarm starts your services and ensures that they continue to run if a server goes down, restarting them if necessary. It makes it easy to scale the number of containers in a service up or down as needed. Swarm even makes it easy to roll out updates to your containers with little or no downtime. The whole process is called orchestration. There are several orchestration tools available in addition to Swarm. Kubernetes, Mesos, and Rancher are among the most notable. Swarm, however, is arguably the easiest to set up and use. Its inclusion with Docker means that there is no additional software to maintain. A Docker swarm can be managed through native tools, including the Docker CLI tool and Docker Machine. Once again, there's no additional software to install. Swarm provides tight coupling with container networks through the overlay driver and other network plugins, which was covered in videos 1.3 and 1.4. Load balancing and service discovery are built in. We'll look at that in more depth in video 3.3. Docker Swarm doesn't have all of the features and complexity of Kubernetes. The simplicity of using Swarm, however, can more than make up for that in many environments. The rest of this course will dive into the details of Docker Swarm. You can find out more about Kubernetes, Mesos, and Rancher in my book, Docker Orchestration from Packt Publishing. There are a few things that you need to do to prepare your nodes for running as part of a swarm. First, your manager node, which is the main controller for the swarm, must have a static IP address. This is how other nodes will connect to and join the swarm. This IP can and should be separate from the public IP address that your nodes will accept public requests on. Next, ensure that TCP port 2377 is allowed between all of the nodes in your swarm. Also ensure that the ports required by your overlay network and storage providers are open. Finally, ensure that all of the nodes in your cluster are using NTP to keep their clocks in sync. Many cloud images have this on by default, but you'll want to make sure. Let's get started building a new swarm. The first step is to initialize the swarm with the command docker swarm init. This can be done remotely through Docker Machine or locally on the server as I'm doing here. The flag advertise-addr is the address that all the other nodes in the swarm will use to connect to it. If your node only has one IP address, this flag is optional. Docker will simply use that IP. If your node has multiple IP addresses, you must specify which one should be used. You can also specify the flag data-path-addr and an IP address to move overlay network data onto a separate network from the rest of the swarm control traffic. If not specified, Docker will use the same address as the advertise-addr flag. Since the nodes in this swarm will only have a single IP address, we'll leave that off. At this point, we have a single node Docker swarm. In addition to the successor failure in creating the swarm, Docker Swarm init also outputs the command to use on other nodes to add them as workers. Don't worry about trying to remember it. You can always ask the manager for the command later. We'll learn how to add additional nodes to the swarm in the next video. In this video, we learned what Docker Swarm is and why you would choose it for your Docker cluster. We learned what steps are needed to prepare your service to be swarm nodes. Finally, we created our own swarm.